All right, guys, this video we're going to go over piecewise functions. We're going to do a Desmos activity on your laptops in class. So this example with Ellis, I'm going to let you guys try this after we've had a chance to do that activity in class. So in this video, I'm going to introduce what piecewise functions are and then get into graphing them, talking about their domain and range, looking at when it's increasing, decreasing, or it's remaining constant, and then ultimately finishing with trying to write a piecewise function based on a graph. Okay, so this is what it looks like. You can see in this example we have a quadratic piece. 1 second, sorry, my pen has to go. And now we're good to go. Our quadratic piece is here. We have a constant term 0, right? That's that line here. Let's do this. I'll just highlight. So here's the quadratic piece until 0. Then we have the line at y equals 0, and then finished with a line with some slope right there. So let's get these highlights going. Okay, so hopefully that makes sense about the different pieces. I'm going to help you guys learn about how to graph them based on, this is probably the most challenging part, is based on these intervals to the side here. These inequalities will tell you when to use each piece. Okay, so let's do an example where we graph one. All right, so I'm going to start by making kind of 3 what are called t-charts with an x and a y, but instead of putting the y, I'm going to put down the function that I'm doing, or at least the piece of it. So I'm going to use x squared first, then the next one I'm going to use 3x, and the last one I'm going to use 6. All right, now based on each of these inequalities, that's what I'm going to plug in terms of my t-chart for the x values. So values less than 0 are like -3, -2, -1. And now here's the first instance where I'm going to teach you guys to kind of break the rule. You'll notice that this one that I highlighted does not have the or equal to underneath, so I technically should not plug in 0 for that part of the piecewise function. But I'm going to go ahead and do it, and you'll see why in a moment. If I don't do it, I'm going to have kind of a little bit of a break in my function. Okay, the middle piece, right? This middle piece has values between 0 and 2, and again, the 0 has the or equal to, so between 0 and 2 is 0, 1, and you could do like 1.99999. But I'm going to plug into, like I did on the first one, I'm going to break that rule to help me give an accurate sketch of what this looks like. And finally, values greater than or equal to 2, 2, 3, 4. You keep going if you want, but that's going to be the simplest just because all those y values will be the same number. Okay, so now if I plug in these x values of -3, -2, -1, and 0 into that quadratic piece, and I square them, I get 9, 4, 1, and 0. Okay, going to this next one, I'm plugging into the middle part of this piecewise function. 0 times 3 is 0, 1 times 3 is 3, 2 times 3 is 6. And last but not least, plugging these into the last part of this one, all the y values are 6. All right, so now when I do this, and when we're going to practice in class, you want to make sure that even though we broke the rule, right, this one does not have the or equal to, so I really should be making an open circle at 0, 0. And then this one does have the or equal to, so that one's going to be closed. You may have noticed when I did that they actually are the same point. So when your open circle and your closed circle happen at the same point, it will be closed. That also happens on the next one. So if I change colors here, right, let's use red. So like this one should be open, and this one, which is here, should be closed. But again, they're both 2, 6. So that's going to be, you're not going to notice the open version of it. All right, but again, that's not always going to be the case. Sometimes you will have some discontinuity there. Okay, so let's plot -3, 9, -2, 4, -1, +1, and I'm going to put an open circle just to follow the rules. But then when I move to the next part, that 0, 0 that's closed fills it in. 1, 3, 2, 6. Oh, I'm sorry, that one should have been open. Let me do that again. So that 2, 6 should have been open. Now the next 2, 6 is going to fill it in. Then 3, 6, 4, 6. So this one should be hopefully straightforward on the last one. This is just a horizontal line, y equals 6. Try to make that first one a parabola, right? I know it can be tough, but trying to make it is a part of a parabola, so it should be curved. And then this middle piece is a line with a slope of 3. So I'm going to just draw that y equals 3x line. Okay, so this is the piecewise function graphed. It does ask us to go ahead and state a couple of things. The domain, all right, when I look at the domain here for my x values, I can plug in any x value I want from negative infinity to infinity. So that's no problem. In terms of the range, it looks like my lowest y value is actually 0. All right, and it is closed, so I use the bracket. And my highest y value is going to be infinity. It does ask about when is the function increasing, decreasing, and constant. And when you do this, all you care about when you write this down is you care about the x values. So if I start reading this like it's a book from left to right, I'm actually, even though my arrow is pointing up, if I jump on this function moving left to right, I'm actually decreasing in my y values. All right, so my y values are decreasing until an x of 0. So I'm going to do from negative infinity to 0, I'm decreasing. Then my y values are increasing from 0 to 2. So increasing from 0 to 2. And then I'm constant from 2 all the way to infinity. All right, and we'll do more about this in class and with other types of functions, not just piecewise, to help you with the increasing, decreasing, and constant. All right, so that's example 1. Okay, example 2, we have 2 separate piecewise functions, f of x and g of x, and we want to do some evaluation. So this is just like you did in Algebra 1, but now you have to first decide which piece or which part or component of the piecewise function are you going to plug it into. And again, like before, it's all based on these inequalities. So you got to first decide where does that x value fall, and that will tell you which one to use. All right, so this first one, f of negative 1. I'm looking for my inequalities here. I highlighted in yellow. Negative 1 is between negative 2 and 0, so that's going to be the first piece. So I'm going to do negative 1 cubed plus 3. Negative 1 cubed is negative 1, adding 3, and you get positive 2. So f of negative 1 is positive 2. Okay, the next one, g of 1. Go into my highlighted in green inequalities. 1 is between 0 and 2, so this is the last part of that piecewise function. So 1 squared minus 2. 1 squared is 1, subtracting 2, and you get negative 1. So g of 1 is negative 1. Sticking with the g function, all right, my negative 4 is between negative 5 and negative 1, so that's actually the first part here. So g of negative 4 is going to be 2 times negative 4, which is negative 8. And then the next one here, part D, back to the f of x function. I'm plugging in 0.5. 0.5 is between 0 and 1. That's the middle part. So plugging in 0.5 for 1/2, I get 1/2 plus 3, which is going to be 3.5. Okay. The next one is f of 1. Okay, this is a good one. This is the first one that has happened where it's actually you have to decide where is the or equal to happening. Right? You can see the or equal to for f of x is here in the last part. It says x is between 1 and 3, but including 1 and 3. So I'm going to use that last piece to plug in 4 plus 1 minus 1 squared. So that's going to be 4 plus 1 is 5, minus 1 squared is 1, and you get 4. Okay, last one for this section, g of negative 0.5. So negative 0.5 is between 0 and negative 1. And that one doesn't actually have an x to plug into. So if you use that part, your y value will always be negative 2. All right, let's do our last example where we actually are given the graph of a piecewise function and they want us to actually write it. All right, this is probably, I think, the trickiest thing and requires the most practice. So we'll give it a go. All right, so I'm going to do f of x. All right, I'm just copying kind of how they wrote these. All right, do the big brace there. And because I have 3 separate pieces, all right, you can see my first piece, my second piece here, and my third piece, I'm going to have 3 inequalities. So I'm going to start going left to right. This first inequality looks like my x values are going from negative infinity to negative 2, but not including 2. So I'm going to say x is less than negative 2. Notice I didn't use the or equal to because that's an open circle there. And then the next piece highlighted in pink is going to be between negative 2 and positive 2. but I'm going to use an or equal to on this one because of that filled in circle there. And then last but not least, this one is going to be x is greater than 2, and because it is a filled in circle, oh, I'm sorry, not 2, I apologize, greater than 3, there's a little gap there. So 1, 2, 3, yep, and I'm going to use or equal to as well. Okay, so for the first kind of rule, all right, for that one highlighted in green, this is a line, and it looks like if I were to keep drawing the line, all right, let's get some points here, trying to find the slope. Here is my slope is 1, 2, 3, 4, 5 up, and 1, 2, 3 over. So I'm going to have 5/3 x. I need to figure out the y-intercept. So I'm going to count 5/3 again. 1, 2, 3, 4, 5. 1, 2, 3. So over here. So the y-intercept, I think is going to be a decimal. I can get it for you in a second. Let me find the other ones first. Okay, and then the next one here in pink is probably the easiest. This is a horizontal line, so it's just going to be that y value of 1, 2, 3, 4. And the last piece is going to have a negative slope. Let's see if I can find another. I think this one is no, I don't think so. It's not hitting there. Let's see. It kind of does look like it hits there. I'm going to go with it, even though it kind of doesn't look like it's happening the whole time. So that's going to be a slope of -2. And then let's find that one. I think I can find the y-intercept a little bit easier. There we go. So that's going to be 1, 2, 3, 4, 5, 6, 7. So +7. And just for the sake of this, because that's not really what we're doing here, I'll go ahead and estimate this y-intercept for the first one is 1, 2, 3, 4, 5, 6. All right, and I'll show you guys in class how you can actually find the y-intercept when you have this information. Okay, this last one, part B. All right, so I'm going to do my big brace. All right, my first piece is very, very small there. It is this part of the line, and it looks like my values are less than -4. Then I have another piece that's this line with some slope. That's going to be between -4 and +2. Okay, and no closed circles, so you'll notice I don't have any or equal to underlines yet. And this last one, another line with some slope, is going to be x is greater than 2. All right, the first one is the horizontal line at 2. The next one, I actually can see the y-intercept, so that's helpful, thank you. So that's the slope of up 1, left 1, so a -x, and I believe the y-intercept is -2. Okay, and then last but not least, I have this one has a +1 slope, up 1, right 1. So if I count here, I can get the y-intercept of -6. All right, this will take some practice. Like I said, this is probably the most challenging part of the piecewise functions, but hopefully you got a chance to see all the different iterations here of graphing them, evaluating, and then trying to write your own piecewise function. All right, come see me if you have any questions. Good luck.